iOS comes with some fantastic functionality for handling networking. In particular, the URL session class makes it surprisingly easy to send and receive data. If we combine that with the codable protocol to convert Swift objects to and from JSON, then wrap that in a URL request struct, which is new to customize the way exactly we send data, then we can accomplish great things in about 20 lines of code. First, let's make a method in our checkout view that will call from our place order button. So I'll say here, func place order is an asynchronous function. It can go to sleep. Now, just like when we were downloading data earlier with URL session, uploading data is also asynchronous. It might go to sleep in the future. So I mark this thing as being async. And now we'll modify our place order button here to call that async thing. I'm going to say the action is place order, like that. And that code, as you can see, doesn't work. And Swift will be fairly clear why. We cannot pass this function here, which is async, to one expecting a synchronous function type. What it means is this button expects to be able to run its action immediately. It does not understand how to wait for something, how to let something sleep for a while. Even if we'd said inside here, okay, let's do a little closure here and use await place order, that still won't work because the button doesn't want to wait. It wants the results now. Now, previously I mentioned that the onAppear modifier doesn't work with asynchronous functions because they also can't sleep. And instead we use the task modifier, which knows how to sleep. That is an option here because we haven't got a modifier to work with. We're running the code directly as a button press. We can't say when the screen is shown, just place the order straight away. We want a confirmation screen, so we cannot use that here. Helpfully, Swift has an alternative. We can make a new task just out of thin air. And just like the task modifier, this will run any kind of asynchronous code we want. In fact, all it takes is to place this await place order call inside a task, like that. Make a new task and call place order inside there. And now we're all set. That code will call place order asynchronously just fine. Of course, that function doesn't do anything yet. It's currently empty. So let's fix that now. In here, we're going to first convert our current order object into a JSON data that can be sent over the internet. We'll then tell Swift how to send that over a networking call. And finally, we'll run the request and process the response. First, those two are straightforward, so we'll just get into it now. We'll use JSON encoder to encode our data as JSON. In here, we'll say guard let encoded equals try question mark JSON encoder dot encode our order, and if that fails, we'll do print fail to encode order and return. And that code won't work yet because it's saying this requires order conform to encodable. If you remember, that's one half of the codable protocol. And so we'll jump over to the order file and say this class definition here, order, needs to be order : codable. That's it. It'll synthesize the codable requirements for us, which is fine. And so you can see it's working nicely here, which is great. The second step means using a new type called URL request, which is like a regular URL, but it now gives extra options to add information like the type of request, what user data should be sent or received, and so forth. Now we've got to attach data in a very, very specific way here so the server knows how to handle it, how to process it correctly, which means adding two extra pieces of information just beyond our order. The first is the HTTP method, which is how we send our data, the method of sending it, right? And there are several of these things out there. In practice, I use get, I want to read data, and then post, I want to write data. Those are the main two methods. And there's a bunch of other ones. There's put and delete and patch and da-da-da. But get, receive, and post, write are by far the most common. And so in our case here, we want to write some data, so we'll do a post HTTP method request. Second, we've got to provide a content type. And that the content type of request determines what kind of data is it we're sending, which affects the way the server handles it. Is it plain text? Is it an image? Is it JSON? Whatever. This is specified in what's called a MIME type, which was originally designed for handling attachments in emails, and it has thousands of very specific options. So the next code in our place order method will be to create a new URL request object, configure it to send JSON data using a post request, and then upload that with our URL session and handle whatever comes back. Of course, the real question here is, where do we send the data? And I don't think you really want to have your own web server here just to handle this little tutorial. So instead, we'll use a really helpful website called recres.in, REQRES.in. It lets us send any data we want to it for testing purposes, and it'll automatically send it back to us. It's a great way for prototyping network coding well, because you'll get real data back regardless of whatever you send. And so in our place order method here, we'll say our URL is the URL with a string of https://reqres.in. And I'll do /API/cupcakes as my exact request. That's made up, but it's helpful. That is hand typed by me. It's definitely correct. I'll happily force unwrap that. Our request will be a new URL request with the URL of that URL. And then we'll say request.setValue. This thing has a slightly reversed method name. That's how Objective-C worked when it was made. We say we'll set the value here for the header, some field here. In our case, the value will be application/JSON for the field content-type. So we're saying this is some JSON data inside our information here, our request, and that's the content type field. And then we'll say request.http method is post. We are writing data. So again, we've got this force unwrap for the URL string here, which means, yes, I know it has an optional URL coming back, but please make it non-optional here. Creating URLs from strings might fail, okay, because you might have put some gibberish in there, for example. Here, though, it's hand typed. I know it's safe. There are no string interpolations happening here. Exclamation marks, perfectly fine. At this point, we are now all set to make our network call, which we'll do using a new method called URL session.shared.upload, along with the URL request we already made. So we'll say do, and then let data underscore be try await URL session.shared.upload for request from that encoded data. And then we'll handle our result here. If we catch, we'll just do print checkout failed with error.localized description. Tell me what went wrong in the debug data here. So we're now uploading it, looking for errors, and we're ready to go to sleep while it happens. Now for the important part. This result here, we've got to read the result of our request back for times when everything's worked correctly. If something's gone wrong, perhaps there was no internet connection, whatever, perhaps recres.in is down, who knows, then our catch block will run as normal. So we haven't got to worry about the hit here. Now, because we're using this test server, recres.in, we'll actually get back more or less the same JSON we sent, which means we can use JSON decoder to convert that JSON back to an object. So to confirm everything worked correctly, we're going to show an alert with some details of the order we sent. But we're going to use a decoded order, not the original order. We get back from recres.in, and yes, of course, it's identical, right? It's basically the same thing. So if it isn't the same, it means we've made a mistake. We asked for 3 vanilla cupcakes with frosting. We get back 5 chocolate cupcakes with sprinkles. Who knows what? Anyway, I'm going to show an alert here just to confirm it will work correctly. So we'll add some new properties up here. We'll say @state private var confirmation message is an empty string. And now @state private var showing confirmation is false. We're also going to attach a alert modifier somewhere to watch this Boolean. and then display this text here when it's true. So we'll add some modifiers down here. Ooh, that doesn't look nice, does it? That's much nicer. Anyway, here we're going to say I want an alert saying thank you is presented bound to $showing confirmation. There's no requirement for a button here, so empty alert is fine because it's just the regular OK button. And then I'm going to attach a message as well. So let's put that. Oh gosh, the formatting here is really horrible, isn't it? Message like that, and then text confirmation message. Eesh. This empty thing here is, you can add what you want to. Maybe I'll add a OK button doing nothing because that's just grinds me both ways. Neither looks good. Oh man, I'm going to add an OK button. I can't handle it. It's just ugly. Sorry. There we go. You don't need it. Again, without that there, you just get an automatic OK button. But I think it looks ugly having the weird open and close brace thing going on. Anyway, with that done, we can now finish off our networking code. We can decode what we get back here in this data object, and then use that to set our confirmation message property and set showing confirmation to be true, so the alert appears. If the decoding fails, if the server sent back something that wasn't in order for some reason, we'll just put an error message. So down here, I'm going to say let decoded order be try JSON decoder dot decode order.self from the data. And then our confirmation message is going to be the information from that order. We'll do your order for, then decoded order, x, order.types, decoded order.type. And it's allowed to be, let me see, dot lowercase, make it look more sensible on the screen. Cupcakes is on the way, like that. Oops, I'm missing a parenthesis here. There we go. On its way. Yeah. Okay. And then showing confirmation is true. And that should more or less work. Let's find out. Press Command R, give it a try. Let's do rainbow, and we'll do 7, and I'm going to say frosting and sprinkles, and delivery can be A is perfectly fine. Checkout, $26, premium pricing. Then place order, boom. Okay, slight mistake there, my mistake. So clearly that's not ideal. Your order for, what did I do? I put the whole order in there, sorry. Decoded order dot quantity makes much more sense, sorry. Your order for, 3x cupcakes on its way. That's much better, I think. So it works. You can select your cupcakes, you can enter delivery information, press place order, see the alert, it all works nicely, which is great. We're not quite done though, apart from that one little bug fix there, because our networking has a small but basically invisible problem. And to see what it is, I want to show you a little bit of debugging in Xcode. We're going to pause our app so we can actually inspect a particular value here. First, I want you to click this line number area here in the gutter, we call it in the Xcode's text editor. Next to let URL equals, press this 55 here for me, boom, and this blue arrow appears next to it, which means we've placed a breakpoint here, which tells Xcode to pause execution when that line is reached, so we can poke around in all our data. Now, go ahead and run the app again. It doesn't matter what you choose. Well, again, I'll just do AAA. Boom, and check out, and then place order. Oh, you heard cupcakes, did you? Fair enough. Anyway, that breakpoint has now jumped back to Xcode. It's paused in Xcode now because it's paused the app with the breakpoint. Say, okay, I'm going to stop here. You can poke around and have a look at your data. That green line is the one, is the one being run right now. That's the one actually being executed by iOS right now. And so we have a chance to stop and look around, have a little think about our data. Now, in Xcode's window, down here is our current data, and down here is LLDB, which is the name of Xcode's debugger. And we can run commands in here to explore our data. And I want to run this particular command in there. We're going to ask iOS to decode the order we received back as a string, convert it back to a string. Is that right, dogs? You love debugging, don't you? So the command for that is P, which means print the value out. Thank you. And we're going to make a string decoding our encoded data as UTF-8.self. So take this encoded object here and make it back into a string, then print it out. You'll think for a second, hopefully, and then all being well, let's find out. It'll print something out. Boom. There we are. Nice little sort of heart-flutter moment being slow there. So you can see it is telling us we have extra frosting, like add sprinkles, It's all there. Dogs, this is the treat box is now empty. This is the last treat, you hungry mutts. And there's two of you. I have to do the cardinal sin and break it in two. Come on, that's it though. This is it. Last treats. Okay, that really is it now. No more. You can see our data's there. It's all working correctly. But you can also see underscore add sprinkles, underscore street address, underscore zip. It's all underscored. Plus we have this observation registrar thing provided to us through the observation system of Swift, the observable macro. Now, in this instance, our code does not care. We will send them all up to recres.in with the underscores in place. It'll send them back to us with the underscore names in place, and we coded them back into the underscore properties. All working just fine. But when you're working with a real server, these names matter. They expect name, zip, add sprinkles, not underscore name, underscore zip, underscore add sprinkles, and so forth. They don't want the weird versions produced by us by the observable macro. And so, to fix this, we've got to make some custom coding keys for our order class. This is rather tedious. Oh, by the way, I just did it, but I'm not telling you. To get rid of the breakpoint, you can just drag it away like that, or leave it in there, I don't mind. We've got to add some coding keys to our order class, which is very tedious to do, particularly when we have quite a few properties like we have here. And so it's annoying, but it's worth doing to get it exactly right, okay? So inside here, add a new enum called coding keys, which is a string that conforms to the coding key protocol. And now we're going to do all the variable names we care about with underscores in front, with a non-underscored string attached to it here. So we'll say we have what we have type, underscore type equals type. We have underscore quantity, which is quantity. We have, what else we got? Special request enabled. Here, case underscore special request enabled is copy and paste like that. We have what? Extra frosting, add sprinkles. Extra frosting is extra frosting, add sprinkles. How did it was boring, didn't I? It is mind-numbingly dull work. Then name, street address, city, and zip. Okay, fine. Get in there. Case names. Name is name, and then city is city. Street address is street address. And then zip is zip. Okay, so we're mapping the internal name, type, underscore type to just type, and underscore quantity to quantity, and so forth. I'm ignoring the registrar, by the way, and just mapping the rest. So back in nothing again, my breakpoint's still there. If you removed it, you can add it again. Again, just click and drag it off to remove it like that. I'll leave it there, though, because I want to press Command R again and see what happens. So I'll go to delivery details and then do again A, check out, place order. It'll break at that point again. You can select LDB down here and just press up on your keyboard to get the last command. Press enter, it'll run it back. And now all the underscore names are gone. It's just city, type, quantity, street address, and so forth. The right names for things. It's much, much nicer. Notice how also the registrar's gone too. So that extra observation registrar thing that's added by observation is gone, which is much nicer. Anyway, with that final code in place, our networking is done and our app is done as well. We're done. Well, I'm done. You still have some challenges to complete.